Welcome to another Geometry Flipped class session. With me, your instructor, Lester Luby Sigumpan. Today, our session number 3, is entitled Angles and Angle Pairs. Today you will learn what angles are, including the relationships of the different angles. Here are the key terms you need to watch out for. We have angle, acute angle, right angle, obtuse angle, straight angle, as well as reflex angle. You would also know what adjacent angles are, linear pair, vertical angles, complementary angles, and supplementary angles, including what postulate and theorem is. Let's start with what an angle is. This is the commonly used symbol for an angle. I'll give you 20 seconds to define what do you think an angle is. Time is up. Now, may I know what are your definitions for an angle? Maybe you said it's a tilt, an elevation, or probably you said sloping. Well, these are all good. Let us define angle as its word. Etymologically, it came from the Greek word angulus, which means a corner. So these are the possible definitions for what an angle is. But mathematically, we define angles as a combination of two rays with a common endpoint. Consider this given figure. We have now two rays, ray AB. Yes, we have two rays now. It's a combination of two rays. We have ray AB, and we also have ray AC. The common endpoint in this figure is the point A. That is where both rays joined. Now, these two rays, ray AB and ray AC, in an angle are called sides. And the common endpoint, which is again point A, is called the vertex. So the parts of an angle are sides and vertex. This shaded figure is what you consider as an angle. Angles are measured in degree measurement. Consider the same figure. How do we name this angle here? Well, you have three different ways to name an angle. Let's start with the first one. We can name an angle using the vertex. Our vertex is point A, and therefore we can name this one angle A. You can also name angle using the 3 points found in your angle. This angle can also be named as angle BAC. Notice that when you name this angle using 3 points, the vertex is placed in the middle. Or you could also name this one the other way around, angle CAB. Consider again, A is written in the middle. You can also name this angle using any number or any letter. Let's say 1, and therefore this is angle 1. Now, when do we use angle A and angle BAC for these angles? Now, take note, they are both the same names. However, if we are consider another ray, ray AD, on the same endpoint A, angle A is not anymore possible to use because angle A is now the bigger or the biggest angle, not the shaded one. This is the time that you can only use angle BAC because it determines the 3 given points. Now, given this figure here, let's test if you know how to name angles. Using these points and these rays, I want you to name as many angles as you can see in 20 seconds. Your 20 seconds starts now. 5 seconds left. Time is up. What are your angles here? Probably you've seen this one. You can name this angle PAN or NAP. Probably this second angle here, angle TAP or PAT. You also have angle MAT or TAM. Aside from these three, we also have this bigger angle, angle TAN, as well as this one, angle MAP, and the last angle possible here is the biggest one, the angle MAN. So we have 6 angles in this given figure. If you name more than half, then that's good, and you got it right. Let's talk about the types or kinds of angles. These are the 5 kinds of angles in comparison to the 3 you've learned during your elementary years. And these are the possible definitions. However, they are not aligned properly. In 20 seconds, I want you to determine what are the correct measurements of each kinds of angles here. 20 seconds starts now. Time is up. Let's match these things, right? How about acute angle? You've learned during elementary years, its measurement is between 0 degrees and 90 degrees. Right? It's actually exactly 90 degrees. Obtuse is between 90 and 180 degrees. How about straight? Straight angle is exactly 180 degrees, and of course the remaining one, reflex angle, is between 180 degrees and 360 degrees. Let's start with the first two. Acute is between 0 and 90 with this figure here. 0 degrees is not possible because there could be no angle for that. For right angle, this is the common figure for this one. Instead of a curved line, we cover it with a rectangle shaped angle. The next three, the obtuse, straight, and reflex, having these correct descriptions. For obtuse, we have between 90 and 180. A straight angle is an angle formed with two opposite rays in a straight line. And the reflex angle is between 180 degrees and 360 degrees with this figure. 360 degrees is also not possible because it is actually the whole circle. Let's start with the first pair of angles, the adjacent angles. I'll give you figures here of adjacent and non-adjacent angles, and I'll give you 20 seconds later on to define what adjacent angles are. Let's start with the first. Angles 1 and 2 are considered as adjacent angles. Angles 3 and 4 are considered as well as adjacent angles. However, angles 5 and 6 are non-adjacent angles. Same thing is true with 7 and 8 as non-adjacent angles. And we have here the last one, angles 9, and the bigger angle 10 are also non-adjacent angles. In 20 seconds, define adjacent angles. Go. Notice the differences of the non-adjacent given angles to the adjacent angles. Okay, time is up. Let's start with the first description. Probably you've said that adjacent angles actually share, yes, same side. Look at angles 1 and 2. They share a same side, as well as 3 and 4. However, for 5 and 6, they are non-adjacent because they don't have the same side. Probably you also said they have the same vertex. For angles 1 and 2 and 3 and 4, they have the same vertex. But for angles 7 and 8, they may share a side, but their vertices are not the same. And lastly, adjacent angles do not share common interior points. Look at the point in angle 2. It's not in 1. Points in angle 3 is not in 4. But point in angle 9 is also a point in angle 10. That's what made a 9 and 10 non-adjacent angles. So adjacent angles share same side, same vertex, but not interior points. Given this figure, 20 seconds, name all adjacent angles you can see. Go! Hurry up! Time is up. Let's see. These are the adjacent angles in this figure. Angles 1 and 2. Angles 2 and 3. And we still have one more. Actually, we have angles 1 and 4. These are the three pairs of adjacent angles in this figure. The next pair of angles is actually named as an angles forming a linear pair. Similarly, I will give you situations here, figures with linear pairs, and it's up to you to define them. Let's start with angles 1 and angle 2. They are forming a linear pair. Angles 3 and 4, they are also forming a linear pair. However, angles 5, 6, and 7 do not form a linear pair. Similarly, angles 8 and 9 do not form a linear pair. And lastly, angles 10 and 11 also do not form a linear pair. You have 20 seconds to define what are the angles that forms a linear pair. Go! Five seconds left. Time is up. Well, angles 1 and 2 and 3 and 4 are in a linear pair because of this situation. We say pair, there must be two angles. Angles 5, 6, and 7, there are three of them. Definitely, they do not form a linear pair. Secondly, you notice in 1 and 2, 3 and 4 that they must be adjacent. Angles 8 and 9, dalawa lang, but they are non-adjacent. However, for angle 10, they are also adjacent and there are only two of them, but they do not form a straight angle. So linear pairs are actually two angles that are adjacent and forms a straight angle. Given this figure here, I want you to look for any linear pair that you see. Timer starts now. Time is up. What are the angles here that you see to form a linear pair? Only one pair. Angles 1 and angle 4. Very good. The third pair of angles is actually called vertical angles. I'll give you again different figures for you to know what vertical angles are. In this first figure, angles 1 and 2 are vertical angles. Similarly, you have angles 3 and 4 are also forming vertical angles. However, the angles 5 and 6 do not form vertical angles, as well as the remaining pair 7 and 8. In 20 seconds, please define vertical angles. Time is up. Now, what are vertical angles? 1 and 2 are vertical angles. 3 and 4 are also vertical angles. But 5 and 6 are non-vertical angles because vertical angles must be non-adjacent. 3 and 4 are non-adjacent. 1 and 2 are non-adjacent. But 5 and 6 are adjacent. But 7 and 8 are also non-adjacent, but they are actually not directly opposite angles. So vertical angles are actually non-adjacent, directly opposite angles when 2 or more lines intersect. It's like 1 and 2, 3 and 4. I'll give you another figure here. I want you to look for a pair of angles that form vertical angles. In 20 seconds, you may start. Time is up. May I know what are the vertical angles here? The first pair of vertical angles you see is actually the pair of angles 1 and angle 6. They are non-adjacent and directly opposite. At the same time, we have angle 4, the bigger one, and angle 5. The fourth pair of angles you need to know are called complementary angles. Instead of figures, I will give you angles with measurements here. Angles 1 and angle 2 are considered as complementary angles. Angles 3 and 4 are also considered as complementary angles. However, angles 5, 6, and 7 are non-complementary angles, as well as 8 and 9. In 20 seconds, please define complementary angles. Time is up. What do you think complementary angles are? Look at the first two pairs. Very good. Complementary angles must be a pair of angles that sum up to 90 degrees. 5, 6, and 7, they sum up to 90, but there are 3 of them. 8 and 9, there are only 2, but do not add to 90. Supplementary angles, on the other hand, just like 1 and 2, and also angles 3 and 4. They are considered as supplementary angles. However, angles 5, 6, and 7 are non-supplementary angles, as well as angles 8 and 9. Similarly, in 20 seconds, define supplementary angles for me. You may start. Go. Time is up. Now, just like what we know, we are asked about pair of angles. Therefore, 5, 6, and 7, there are only 3 of them. Therefore, it cannot be. And what you have noticed here is actually they must sum up to 180 degrees. Angles 8 to 9, 170 degrees only. Now, those are the 5 pairs of angles that you know. However, there is a good relationship for the pairs of angles here. If 2 angles are supplementary, they must sum up to 180 degrees. And if they sum up to 180 degrees, they may form a straight angle. If that is the case, if they form a straight angle, they're considered as linear pair. Similarly, we can do backwards. Angles that form a linear pair form a straight angle, measures 180 degrees, and therefore linear pair angles are supplementary. Again, Angles that forms a linear pair are supplementary. Aside from the angles here, you also need to know what postulate and theorems are. A postulate is actually a statement in geometry that is accepted true even without proof. A theorem, on the other hand, is a statement in geometry that is only accepted true if proven first. All relationships and definitions later on in geometry will be considered as postulates and theorems. So we need to know what postulates and theorems are. But if you are presented first with the theorem before we will accept them, we need to prove them first. Just like the first theorem you will learn in geometry, the vertical angle theorem. It states that the vertical angles are congruent. But since it's a theorem, we need to prove this first. Given this figure here, we know that angles 1 and 2 are vertical angles, and therefore they must be congruent for vertical angle theorem. But then again, we need to prove them first. First relationship that you see is for angle 1 and angle 4. Angles 1 and 4 form a linear pair. Aside from that one, angles 2 and 4 also form a linear pair. This would be helpful for us to prove later on that angles 1 and 2 are congruent or have the same measurement. If we use the same angle 4 here, that would mean angles 1 and angle 2 will be congruent because angle 4 are just the same. If you are not solved with that, let's use values here. Let us say angle 1 is measured with 70 degrees. Since angle 1 and angle 4 forms a linear pair, they must be supplementary. Angle 4 is 110 degrees. Angles 2 and 4 are also supplementary because they form a linear pair, and therefore angle 2 is considered as 70 degrees as well. Look at the relationship of angles 1 and 2. They have the same measurement. This is a proof that vertical angles are congruent. We have proven this one. Here are the key terms you need to remember as we end this lesson. We have here angles, the types of angles, the pairs of angles, and most importantly, the statements in geometry that you need to remember from time to time, the postulates that are accepted true, and theorem that will be accepted true if proven first. If you were able to view this video, I would like you to comment these numbers that corresponds to your name in the comment section of the Schoology. It's very important for me to know who are able to view this video and if you're ready for an activity. If your names are not listed here, probably it's on the next slides. I would like to remind everybody that this instructional video can be viewed from time to time, and you can re-review this one for your own benefit. If your names are here, please comment the numbers that correspond to your name in the comment section. In our next class session, you need these numbers because you might be grouped with the same numbers as the other students here. But first, I would like you to comment the numbers that corresponds to your name in the comment section of the Schoology. Well, that's it. That's a wrap. Be excited for our next session. Our next session would be entitled Parallel Lines and the Transversal. You need to learn what is the relationship between the transversal and parallel lines, and probably you might notice there another set of angle pairs. We are going to tackle them next meeting. That's all for today. Hopefully you've learned. Thank you, and once again, good day.